Yeah, so something that spun up from a talk, I think one of the lean coffees, or maybe precursor or a postcursor, if that's a word. I talked to Joel about kind of my fascination with some cloud functions and kind of cloud in general. And so he suggested to do this talk, and I jumped all in on that. So we call it the CompareTo Azure versus Google Cloud Functions. Mainly, selfishly, those are the only two cloud functions that I played with so far. I will add AWS to that shortly. But what I want to go through is just some stuff about serverless, about cloud functions, and more so, you may notice there's a lot of wind up to it, as I do want to kind of talk more about how we got to where we are using serverless instead of just going right into it, mainly because I want to have some more content than just possibly 5 minutes. So at the end of this, we'll also, let me just go to the agenda here. Like you see, at the end of it, we'll actually demo building a simple JavaScript function app and deploy that to Azure and Google Cloud, so we can kind of experience the different frameworks for each, and excited to share that with you. So quickly, I kind of covered some of it, but in terms of agenda, because we should see where we're going. What is serverless? How did we get here? How does it work? I broke it down in a simple analogy that I think makes sense to me about not only serverless, but how about the overall cloud evolution and transformation from where we were, maybe just 10 years ago. What are some of the limitations of serverless? What are some implementations that are well suited for it? And then, like I said, a couple of demos and the questions. So without further ado, I want to talk about what is serverless. So serverless is a form of cloud-based computing that attempts to abstract the machines, virtual machines, network, storage interface from the actual application itself. Obviously, the servers are still used, so the name is a little bit of a misnomer. But the key fact is to abstract the actual how the thing is working, how it's deployed, how a request is getting there, and let developers just focus really on just building the thing to solve the problem to bring business value. So I think that's really why we call it serverless. I think there are some paradigms that make it make sense, right? I think you can think about it as a server is not always running. This is something I will repeatedly get into in this talk, but the server is not constantly running. It is kind of not running and then running when it's needed. And I think this is one of the things that fascinates me the most about this. And so I'll kind of talk through that a little bit. And yeah, I think the rest is just kind of more what I rambled on about. So here's the kind of, yeah, Gugu.
Yeah, quick question. So I'm here to learn. I've played with it, but I haven't really put any big application in production. And I'm working on a small project to try and do that. So as you're talking here on the first slide, what pops into my mind is how long has this serverless technology, say, been around? Did it just catch steam all of a sudden, or it's something that was there a long time ago? What do you know about that?
Yeah, that's a good question, Gugu. And I thought earlier to add that to the slide, and I forgot. I think from what I remember reading about, I think Amazon Lambda functions were first, and it was in 2014. So so not too long ago, but also in kind of the rapid pace that we change that computing has been recently. That is quite a long time ago. So depending on how you look at it, I think it started off. I remember reading about it for a while, but I think it wasn't always. For some reasons, we'll go into later. It wasn't fully practical at the beginning. I think it was a good idea, but the one what we'll refer to later and talk more about as a cold start problem was a little bit more pronounced earlier. Things took longer to start up, so the workloads that you could actually pull off with serverless were a little bit more limited. Now, as we'll see in the demo later, I mean, the things can spin up so quick that really it's harder to find an implementation that will not work with serverless than will. But I'll carry on, but that's a good question right there. So it's been about 6 years. Yeah.
Just one comment though, I do see some employers asking for 10 years of experience in serverless. which is why I asked.
Oh, okay, yeah. They're looking for yeah, I don't know. So it's probably older than 10 years. You're absolutely right. It's kind of like we're looking for senior Angular 7 developers, with 10 years experience. But no, I hear you. It's probably been around for a little bit longer, but I think that's when at least from the Lambda picked it up. So anyways, yeah. I'll keep going on this. This is something that, this has kind of been my journey, and I think very much Gugu's journey as well. What we're looking at here, I wanted to kind of, this is more cloud-based, not necessarily just serverless, but I want to see, I'm very fascinated with cloud just basically because I've been in the other side. And so what I wanted to convey in this picture is the old way, and this is, again, right, this is late 2000s, early, at least from my experience, early 2010s, right? We're deploying applications on we're deploying clusters of VMs all running basically one workload, right? So we want to have one app, we want to have 4 instances of it. That means we're basically spinning up 4 different VMs. We want to scale more, we're just throwing more VMs at it. And that's one thing, but the thing that I think was problematic more than that is we're not filling these VMs with a lot of work. They're mainly focused on very few amounts of apps. There's a lot of wasted compute and wasted wasted dollars that are just kind of sitting there while these servers are running constantly and not taking the load, for instance. And so as you can see here, each VM is having the fundamental computer problems, network, memory, CPU, storage, and it's running some application itself, right? There's no shared assets going on, and there's just a lot of kind of compute that's being wasted, in my opinion. So key here is no matter if a server is serving up a hit or not, it's running constantly. It's constantly running. We're paying in data centers for the servers to run, all that good stuff. We're scaling horizontally if we need to add more capacity, right? So I'll kind of go to the next step down the road is recently, a few years ago, maybe 4. Gugu, don't ask me when Docker came around because I'll probably blow some more smoke there. But I think the next level that I saw in my career is kind of the use of app containers. Obviously Docker. So this was an ability to kind of fill out more of the VMs with more applications, with more containers, and really utilize the full amount of the VM and not let anything go to waste, right? So, but we're still in this model, we're still running these VMs constantly, no matter if they're under load or not, right? If you're under heavy load, it's great; it should be running nonstop. But what about in the middle of the night? Maybe your workload isn't 24 hours. You've got a lot of compute that's just spinning. It's just racking up costs. It's racking up, compute hours, and that's adds to the price. So in this instance, I'll get to scaling horizontal in the next slide. We can scale vertically by just basically using a beefier VM, fitting more containers in there, using Docker to manage that. And I think here is our first point where we are sharing network storage, CPU memory. Multiple apps are sharing that. It's more efficient. That's my main kind of focus point there. So kind of on a similar situation, we're still using Docker on the VMs, but we're using more of like a container orchestration. So this is like your Kubernetes, Pivotal Cloud Foundry, OpenShift, other kind of abstractions, implementations of continuing to use VMs, using Docker containers inside the VMs, and having some kind of orchestration scheduler, some kind of a tool that is managing, okay, how much of each app container is on each VM? How are you going to load balance the load to each of them, either internally on the VMs themselves, something like Eureka or some kind of like a discovery service, or you have a hardware load balancer in front of the whole cluster itself, right? So I think this is where we start to get, all right, Google Cloud Platform, Azure, AWS, these managed Kubernetes orchestration products are quite good at this because they really start to take away. You're not spinning up VMs yourself. You're not, you're not managing the routing. You're not doing all the Kubernetes orchestration will do that for you, but it's still ultimately using VMs that are running constantly under the hood. It's just, doing more orchestration, taking some out of your hands. But again, to the point, and I'm kind of trying to really drill this in, these servers are still constantly running, constantly racking up costs, right? So this is better than the previous slide, but I think it's still, it still can go to a next level, right? So this is where, okay, now we're finally into the serverless pattern. And this is kind of a high level diagram that I put together. This is kind of how I think about it. I kind of have this broken up into the next slides to make it maybe kind of the flow makes sense. But, from my understanding of serverless, where it's going to the next level of abstracting the VMs, the machines, the network, the CPU, even the containers, everything away from the developer, and only allowing and getting it so that the developer is only focused on the actual code that they're building to do the thing that brings the business value. And really that's it, right? Your specification of what kind of runtime you need, and then you fit into some kind of general pattern of what the platform needs. And then the rest will, the platform in this case, what we'll show is Azure and Google Cloud. It will handle all of the orchestration, spinning up the VM, getting the container on the VM, getting your application on that container, starting the container up, getting the request, routing it to that container to serve it up, and then the opposite, spinning it down. So, the key thing here is kind of like I said, containers are spun up in real time. We're not constantly spinning. Scaling is elastic, right? You can scale as much load as you need, the platforms will give you, right? So that may mean your use case needs 1,000 VMs at some point, and other times it maybe just needs one every couple hours or so. It'll handle this all for you. The developer, the team does not have to manage the VMs. There's no server maintenance on the VMs. There's no IT team, so there are trade-offs, and we'll get into that in a little bit. And then key point here is the VMs are not running constantly, right? This is where I get the most jazzed about. I mean, all the other stuff is cool, all the abstraction, but I mean, you're only paying for hits that you are actually serving up traffic, right? This is something that is just completely a paradigm shift from what we've always done, in which case, okay, you have to plan out your max amount of load that you expect, and then you got to just run the servers enough to handle that max load. Okay, well that's great. But what are your min load times? You're hemorrhaging money in terms of paying for compute that's just spinning, right? You're just basically paying for ones and zeros to cycle, right? So I think this is where we get to. So I just wanted to break it down into step by step. Again, full disclaimer, I have not developed my own serverless platform. I don't know all the exact, I may misspeak on some of this, but I'm looking at a high level conceptual view of what happens. And so, you set it up. Yeah, Gugu, yep.
Yeah, Bryce, before you get into this, can you comment a little bit about the progression you've shown up to this point? As a developer, how harder or easier has it been to develop in these different platforms? What kind of mindset change do you need to have as you go from a VM to, we used to need to know how to configure Tomcat.
Yeah.
Now all of that stuff is gone.
Yeah.
So talk about that journey as well.
For sure. I think that's a great call. I would look at least in my experience, it's been at these little shifts, right? I think from at this point, you're thinking more about Tomcat, and you're thinking about more specific. You're building something to fit on a specific server instance, and it's more particular, right? I would say that at this point is where things became, at least for this and the Kubernetes, it became one thing, right? Here, when you got containers involved, if you're lucky, like Gugu and I have been, I remember Gugu, you brought up Spring Boot to me for the first time, and back when we were kind of transitioning from this to it, and I was like, that's all right. And then I was like, all right, Spring Boot is the way to go. Here, you're just learning about, you're just focusing building cloud native applications. You know, if it's Spring Boot, for example, it's got a jar. You can run it easily locally. You can just deploy it to Docker very easily. You can deploy it to then you get here Kubernetes, Pivotal Cloud Foundry. You know, these are all kind of based on if you're in a Spring jar, things are working pretty well. And so I think that's where these had the similarity. Granted, on this screen, Pivotal Cloud Foundry, you're focused on deploying the jar with a build pack, right? Whereas Kubernetes, you're actually building a Docker container that's running your jar, and then you're kind of like allowing Kubernetes to orchestrate your jar, your Docker container around. But the nucleus, I think, is still the kind of jar self-running job application in my experience, right? And then I think to your point, though, here is where things change. I think there is some overlap, right? There is some serverless that uses Docker containers, so obviously that familiarity will be there. But another case of it is that, no, you kind of have to take advantage of what's going on, which I'll kind of show and we'll kind of showcase in the demo. You're doing things a little bit differently, and it's kind of a breaking of that pattern. So I'd say those are the transitions of where I found a different experience. Yeah.
Hey,
Joel, are you coming on? Yep.
Hey, I got some questions in Twitch, and I wanted to. Is this a good time to ask them?
It's a good time to answer and ask them. Yep.
All right. So we got M. Clayson. He hangs out here a lot. He says, moving from bare metal to VM to containers to serverless, has reliability changed for each of those steps? Reliability meaning uptime.
So I think that I wouldn't say they necessarily have a direct correlation in change. I think that running bare metals, running VMs in a bare metal server, right? Running a Docker container, I think you're still, if you had a good environment, you have good uptime. If you didn't have it, if you had some kind of, budget servers or budget data center, so I think you may be more vulnerable. I don't know if the actual pattern necessarily changes. I may be missing on that. I think my main focus or difference I've seen has not been about like an increase in reliability. It's more of an increase in using the resources efficiently. I think that the biggest change I feel from going to bare metal, especially to VMs to then containers, you're just efficiently using that compute. You used to run 5 VMs to run. You have an application that has 5 instances because you need to share the load. You're running 5 servers or 5 VMs. Right now, you containerize it. You could probably run that on 1 VM and get them all in there. That's kind of the picture. But I think there probably is some reliability change in there. I don't know. I'd like to hear Gugu's opinion on that. If you can think of anything I'm missing.
Yeah, I was going to answer it differently, but I think you swayed me to your way of thinking there.
Nice.
With containers, it's spread across multiple servers, but then you could also build the right pattern with bare metal, where you have the redundancy and load balancers. One server goes down, just routed to a different server. So in that respect, I think you're absolutely right. The focus is on the efficiency outside.
Yeah, and I think that's a good call. And I think you made me think about it the other way too. That actually, yeah, I think it's all about how you do it right. And I love this question, by the way. I think it's all about how you do it right. But then I look at the example I just said. You put 5 instances on one Docker, on one VM running Docker, right? Now your point of failure is that VM, whereas before you had it spread across 5. So I guess in that sense,
you would have been wrong, right?
Exactly. No, exactly. So that's where I think you really lean on. That's why Kubernetes, Pivotal Cloud Foundry, they're all multi-zone clusters, right? You're not just running it on one unless you're okay with there's an outage because of a single point. So yeah, absolutely. To your point, nothing has dissuaded you from being able to architect it in a way that is reliable. But yeah, they have different vulnerabilities for sure. So yeah, excellent question and answer. Joel, anything else?
Yeah, I'm just making sure that we don't get feedback here. Oh my goodness. So there's a whole conversation breaking out on Twitch. Yeah, Gugu, why don't you keep an eye on that with me? And if there's really a question that want to be asked, can you just put question marks on it? Because I love the conversation going on. But
oh no, is it a bunch of like Gugu and Bryce don't know what they're talking about, and let's talk about it here separately?
It's incredibly nerdy. They're discussing reliability and all that stuff. So maybe we'll circle back. If there's really a question, happy to ask it. But let's keep going ahead. Let's keep pushing ahead.
All right, that's great. All right, so coming back to serverless, I think this is the high level. I really want to get into the breakdown. So here I kind of like mentioned the life cycle here, but I want to do it in different slides. So first off, a request comes in. The platform. So look, in this situation, there's no runtime. There's no app running, right? No one's paying for anything right now until the request comes in. Azure, Google platform, they know, okay, this request is mapped to this this function app, this cloud function. So okay, I need to start building things up. So it's going to pull in from its its available containers. It knows that this request is serving up a JavaScript app that needs a Node runtime. So it's going to pull a container that's got the Node runtime, and then it's going to start running that application that you've made, which maybe is just a single method, a single JavaScript method, and it's going to then have that running, and then the request is going to get routed to that container, and it's going to serve up the request and then return the response. So one thing to conceptualize and look at in the JavaScript implementation, we'll show this in a little bit. The function that is being run is like a method in a Node Express app, right? The framework is based on Node Express, at least in the HTTP trigger mode. So if you were to run a Node Express app on your local machine or deploy it, and you've got one endpoint and then it routes to a JavaScript method, that method is the unit of work that you are making a cloud function of, right? Azure, Google Cloud Platform, etc. They will manage the whole, like, oh, you need an Express app, you want this routing, an API endpoint hits here, and then it calls that method. Okay, all that stuff that you would have in like your app.js or server.js or whatever, that's what the platform brings you. You're just giving it the method and then telling it, when this HTTP call comes in, I want this method to be run. And we'll show that a little bit later. But so kind of want to see if make sure I said here, and I kind of bolded the cold start here, because obviously if you can think about it, the thing that has made this hard for us in the past is the cold start problem, right? The reason we have servers on the ready is because, especially if Google and I are from the Java world, right? Starting up a Spring Boot app takes, a long time, right? Nowadays, it's, maybe 10, 15 seconds if you're connecting to a DB, maybe a couple seconds if you're not, right? Back in the day, right, I got apps that, I still kind of manage now. It takes a minute and a half to start, Tomcat 7, Java 8, thankfully it was Java 7 recently, but, so that's always been kind of this problem where it's like, okay, we can't have this on demand starting the app up. It just takes too long, right? That's changed now with for the Java use case. There's Docker containers where that kind of allows it's a much quicker startup than doing like a full Java start, right? In Node, in the JavaScript world, which we'll just show you, it's super quick. Anyone that's run a Node Express app, when you hit Node server, Node server.js or whatever, it comes up pretty quick, and I think that's probably when I can't speak for whoever created this, right? But like the aha moment must have come up in someone's head, or I wish it was my head, that it's like, all right, this is a perfect use case for us to do some kind of serverless thing, because I mean, if you can have a 500 millisecond kind of wait time just for that to happen and then route the request, and that saves us from running this nonstop, I mean, that's the dream right there. So. And one thing I wanted to highlight, I should have probably done more research on this. I'm okay if I get caught up for not knowing much, but something I have read before is that obviously these large cloud platforms are very smart. They've got a lot of brilliant engineers and a lot of money. They're developing AI patterns that notice, workloads based on, when they expect the load to come, and they're preempting containers, and they're so if they can have things running before the requests come, they're going to hit their SLA, they're going to return in enough time, and they're not going to have to battle this cold start problem as much, right? And so I think that's where, down the road when we think about, okay, what kind of workloads can go in here, I think, that's how they're allowing a lot to be able to be done because of this kind of like ingenuity. So this is kind of and then after all this, I kind of took a side trip there. At the end of the request, if there's nothing coming in after a certain amount of time, those containers get destroyed and then they're stopped. And then, Azure, GCP, they're not running the machine, so they're not paying the compute. We as consumers are not paying for the compute because things aren't running. So I think this is like the dream scenario, right? And it's something I'm kind of really geeked and jazzed about at a high level, conceptual, like focus on the cost standpoint. So I'm switching to do another gear here next. So I'm okay.
Yeah. I have a quick question or comment rather. I think along the way, one thing that was transformative, at least in my mind, was turning storage into a service, like the S3 buckets and things of that nature, where with those 4 core components that you started with, network, CPU, storage, and memory, those were kind of broken apart and you could charge people differently when using those separately. And that's a break from our computer science 101 when we learned about those 4 core fundamental items for computer science.
Definitely. No, you're right. And I think it all comes down to this, if I can go back up here, like it's just different levels of abstraction of those fundamentals, right? From bare metal, like you said, you're dealing with it on every node that you've got, right? Then you start to share it amongst applications. Then you start to like scale, this is just an ability to scale more, but still kind of taking advantage of that. Here is like a complete abstraction of that, right? No one is paying for no one's paying separately in serverless for the network, for the storage, for the CPU, for the memory. You're paying for a function to be run when a request comes in, or or whatever is triggering that, and there's multiple triggers. I'll tell you, you're paying only for that function run. Granted, you're paying for all the other stuff too. There's no paying for it, right? But it's just like you said, it's more of a service. It's more of like a commodity. It's built in to the function run cost as opposed to, okay, I need to pay for the max amount of network I'm going to need. I'm going to have to pay for the max amount of memory that my load is going to need. And so, yeah, I think it's a fundamental switch. Is a great point for sure.
Hey guys, we had a question on the Twitch stream from Night Lil YC. The question is, with container orchestration, i.e. Kubernetes, you sometimes need to look at limiting access to applications to a select few applications. How does serverless restrict application access? i.e., I don't want my calendar service to start making calls to my finance service, aka limit damage if an application is compromised.
Yeah, that's a great question. So I know in Google Cloud Platform, you can set up for different service accounts to be able to call the function. So that's if it's an internal, like for instance, a cloud function that's listening on a pub sub topic. In the HTTP trigger world, I think that's a great question. This is a little bit less kind of sophisticated, I would say. In both my experience in Azure and Google Cloud Platform, you can have a protected API trigger, but it basically gives you like an API key. So it's a static key. I haven't seen any kind of OAuth. Granted, I may have missed some. I know in GCP, it's maybe more likely that you can do some. But from what I've seen is they do protect the endpoint, but a lot of times it's just with some kind of static API key code. So I think that's decent. I think it definitely allows you to kind of revoke access to that and kind of easily turn off if things have been exploited. But probably for some kind of security gurus, more focus on that, it may be lacking a little bit.
I think what I've seen is most of that stuff is handled by your Kubernetes or your OpenShift. That's where you configure some of this. And another approach is just to move everything up to an API layer, so the proxies and the rules and everything, and this request has access to go to this container can be configured away from the containers. So it depends on what kind of architecture maturity they're running, I think.
Definitely, for sure. Definitely. Thanks, Gugu. And great question. All right, so this is, I really wanted to put this because this is, I know this is kind of rehashing what we did and it's kind of getting off of serverless, but even though it's at the end, this is kind of the way that I visualized this whole journey, right? And this kind of made the most sense for me. It's kind of how I visualize. So, when we first started it, we're looking at it's kind of like that age old, like, when we're kids with marbles in a cylinder, guess how many marbles are in there, all that stuff, except this doesn't really involve the guessing how many, but I think that analogy just stuck with me, right? I think when we're first talking about like single VMs per app or bare metal, right, same thing, we're using a huge cylinder and we're using one marble and there's a bunch of empty space, right? And that's the waste in my opinion, right? Then we go into the VM with containers. Now it's like, okay, you've got the same size cylinder, maybe bigger, right? In this case, the same size, and you can fit more marbles in there, right? So you're using that space better, right? Container orchestration, Kubernetes, PCF, et cetera. Now it's just kind of similar play, except you have more of an abstraction management in that, but you're just using more cylinders efficiently, right? That's kind of where we in my mind, I think that if you talk about the fundamental paradigm shifts, I think it's in the first section where we're going from single VMs, bare metal, to containers. I think Docker containers, I mean, that's massive, right? Because then it's more easily, you could always, I think there's an argument out there, one VM doesn't have to only be running one app, right? I just think this is how in enterprise we saw it a lot. Maybe it's just kind of a setup or a security, but you could definitely run multiple and then just route internally and all that stuff, but it's way more complicated, right? And so I think then like with Docker, it allowed this abstraction where Docker can take care of the port mapping, the routing, all of this stuff, it's more accessible, right? And then container orchestration so I see the fundamental changes in the first section. And then obviously we go from this out point. When we're talking about serverless, I look at that as like a marble, right? You don't care about the cylinder. You don't care about the other marbles, right? The developer can only care about the marble. Even like I put the node runtime here or the Java runtime, whatever. Really, the developer only needs to focus on this inner marble, which is just the function itself, right? I think that's super powerful. I think it gets developers, they can focus on much less things, and the platform can kind of take care of much more of this maintenance and other activities. So there's a conservation of work that's needed, obviously. It's just who does that work, right? Development teams don't need to be bogged down with where they're deploying to, what version of Tomcat they're on, what version of Java they need to run to make it work, right? And that's not a serverless chain. That's kind of, we're getting that kind of earlier up the chain too. But that's kind of what I think the really abstraction value that we get out of this whole journey. So this is kind of what gets me going. Yep.
Oh, wow. You blew my mind, Bryce. I think that was a really great analogy and a great breakdown. Well,
Thanks.
Made sense to me, at least.
Thanks, Gugu. Yeah, we'll see how Twitch, how it made sense to Twitch or if it's too childish. But yeah, I think this really hit it home for me. It's just, it's all about efficiency. It's all about minimizing costs, right? That's kind of where, as an enterprise leader, like that's been my kind of focus, right? So, all right, so here we go. Here's the good stuff, right? What are some of the limitations, right? So obviously, like we talked about, not all workloads are going to work here. Even though the cold start, the kind of the performance has increased greatly. Not everything is going to be possible to use here. Highly available requirements. Extremely high volume throughout the day, right? No nonstop kind of a thing, right? A lot of cases you can make the argument that that's better off done in a standard kind of Kubernetes cluster, PCF, that kind of a thing, right? Another big thing that is a challenge is it does make the overall architecture of an application or system more complex, right? You don't have easy ability to track trace requests, logging, getting your metrics or viewpoint of kind of where things are going. Monoliths are obviously much easier on that, but then it's a trade-off because you got a huge monolith. maybe microservices on other containers. It's still a bigger domain, right? We're talking about the function level here instead of like a domain level. So I think there's some complexity there. So in observability. And another big one, possibly to a lot of people, is there's an extreme buy-in and lock-in in terms of vendors, right? So you can roll, this is something Google, I know you'll bring up later, you've asked about it earlier. There is ability to run your own serverless, right? But that kind of takes away the going away from complexity and just adding a bunch of complexity. But I mean, smart people can build their own service here, and do this kind. But a lot of you, if you want to really take advantage of kind of tried and true, you're going with a vendor that's providing this to you. It may be hard to switch to the different vendors, multiple cloud environment, multiple vendor kind of situations may be challenging. So there absolutely is some kind of vendor lock-in that this may cause, right? So I'll go to the next page though. And this first point is, this is what really another thing that hits at home for me. Serverless, if you can use a heavily serverless architecture and do it right and do it where it fits your business, it is significant. And I think this is an understatement. It is significantly less costly. You're talking, I think 70, 90% is what I saw some figures. I think it's possibly in most cases, especially for small companies with kind of more flexible workloads, it's probably close to 99%, right? Savings, right? I did the Azure calculator, and based on you get some free requests. So I think that may be scaled differently based on how much use case. It was like 1.2 million requests at an expected SLA of 1,000 milliseconds, so 1 second allowed response time. It was 20 cents a month. You had to go over 1 million requests to even get a number to show up in what you would have to pay, right? So I think that is like staggering to me in terms of what some of these trade-offs that we talked about are versus just significant cost efficiency that you're getting. If I was developing a startup and could start from scratch and could really think and spend all the time in it, I would do nothing but serverless until like something really forced me not to. The elasticity of the platform, right? You basically have elastic scale in terms of what you can handle. You're not saying, okay, I've pre-purchased 20 VMs, so if I hit that max, then I got to go in and I got to add more, and then my cost is going to go up, and all this. It's like this will just scale to however many you need. You may pay more, maybe you'll pay $1. Maybe you'll pay a candy bar amount, on a good Black Friday day, right? So I think that kind of like it abstracts everything from it is a huge benefit. That's the next point. You don't have to worry about a lot of these actual like nuts and bolts of how things are working. That may be a downside to some people, right? But I think that's it lets developers focus on what they want to do, and that's building value, So just from my experience, and granted it's limited, right? Like I said, I've been from the old school way. So, I'm trying as quickly as I can to get into the newer, but some things I played around with recently is anything that's webhook related, right? Something that you don't have a customer on the back end waiting for something, but it's just like a server to server call. That's perfect for serverless, right? I wrote a Twitch listener so that, when my favorite Twitch streamers like Canton Coders started streaming, it would notify me in Slack. And I built that in a serverless thing. I know Twitch has a function to do that for yourself, but who wants to use what's already there, right? I built some stuff in for my employer to kind of help automate between our build server and our chat system, so that we could go from a build goes off, it updates Jira stories based on what was in that build, and then it sends a message to our release chat to say like, this is the release that went, these are the stories that were in it. Another work thing I did in Google in GCP was writing some. We had some ingress egress using PubSub topics, and so we just put a cloud function listening on a PubSub topic, so that when the message hit the topic, we then put something in the Cloud SQL or something like that. So really there's tons of use cases. I think if you can handle 1 second or more, even half a second or more response time for something, serverless is most likely is going to work for you. With the limitation that obviously you can't code just any way you want, and there is some added complexity, like we talked about before. So with all those caveats, there are really a ton of good uses for serverless architecture. So I'll pause there. It's been 45 minutes of me talking. I love to go into a demo where you can see if Gugu and I can solve FizzBuzz after all these years, and then deploy it to the cloud. But unless there's any questions out there or from you, Gugu.
One thing I wrote down here is with regards to OOP programming, just patterns in programming where I have a controller, a service, and that kind of stuff. Does that play into this whole micro functions?
Yeah, I think there's argument that it doesn't really. Yeah. Like if you're breaking it down into the methods, you're already kind of drilling to a very narrow focus. Now, I think inside there, obviously, you can still develop object-oriented, and then you can still, I think they can still use other services. I think you still have that there, but yeah, there is kind of a heavy decomposition of components of domain in this pattern. And so it may be that it is a little bit more disconnected. Maybe there is a difference in terms of what you can share. But then again, I think you can always develop, and to your point earlier, plan the architecture and design in a way that, yeah, what you are exposing in the cloud is a single method, right? But that doesn't mean it can't come from a heavily, hierarchical, inherited, object-oriented kind of a code base. It's just what you're ultimately exposing, maybe more on the micro level than that. But that's a good question. I would probably need to spend more time in diving into that. I think my first feeling is that it's a little bit less than that, but I very much could be wrong on that.
How about testing?
I knew you were going to ask that one. Yeah, I think that.
Of course, did you see the first Canton Coders?
Yeah, when we're doing the unit the test-driven development methods
with the Finsters.
Yeah,
the proper way to develop is to think test first. That was my biggest takeaway. So now, when I plan to build an application, when I plan to stand up a CI/CD pipeline, I'm thinking first, how is this going to be tested?
Yeah. And
so bringing that to serverless, how am I going to test it? How am I going to regression test it? How am I going to,
Yeah, no, for sure. I mean, I think that ultimately, like my previous point, a lot of these methods are coming out of like what you could quote package in an overall, like in the demo we'll go in a Node Express app, right? So however you're going to do your test-driven development for that, you can still do the same. It's at the core. It's still just a Node app. It's just you kind of are decomposing it in the cloud for deployment, right? But ultimately, as a whole, it can still be under the exact same testing criteria like that. I think on the CI/CD pipeline part of it, I think that's something I also haven't jumped into as much either. I think, but like we'll show here in a second, I think the Azure deployment process, I think, would be very much CI/CD-able, right? Because it's much more like automated. I think GCP, I've been corrected recently, I think does have, by you actually, and then others from work, there is ability to do it in a more automated fashion, but it's not as straightforward. And so what you'll see me do today is just basically copy paste code into a UI to get it deployed. And obviously that's a little bit more challenging unless you're going to run like Selenium to like be your CI/CD pipeline, which just sounds like a really bad idea. I think there's room to learn on that. I would suggest maybe someone to do a test-driven development cloud function presentation. I'm probably going to get kind of crucified for this one, but I am not the hugest test-driven develop.
Oh, this is oh no, my computer broke. You guys still hear me, or did it drop?
Yeah, we can hear you, but we can't see. Oh, now we can see and hear.
Yeah. You realize cameras have to be plugged in to work. No, it's Canton Coders, right? We all have our own opinions, and we don't really judge each other unless it's silly things like saying things like PHP is really a programming language. It is, right? It is.
Oh man, Google and I are PHP like gurus here,
He's
man.
poking at us, man. He's poking at us.
Yeah,
All your
Don't
students
open
love
that
the
door,
PHP.
man.
you know, some of the most, one of the most, like, maybe not profitable, but one of the most famous applications out there started in PHP. All right, a highly optimized, compiled, crazy version, and obviously it's pretty much broken our entire social construct. But I mean, that was PHP. You know, you got to give it to them. So. Oh, you said no political men. I think I broke the disclaimer there. So, all right, should I go on to the demo now?
Yes, please.
I don't know. I don't know if people really want to see real code.
Yeah, I know, exactly. All right, so let's do this. So, all right, here's the journey that we're going to go on. So I'm going to start with Azure. First things we got to do is, so if you're not familiar with this Azure portal, if you want to play around, you can just create a free account. I think you get $200 credit first. It would take us a lifetime to use that in Cloud Functions. That's just my, again, not so subtle point, but it's very easy to start playing around like it is on most of these cloud platforms. So this Azure portal, I'm going to go to the function app section, which is what they call their serverless. I had already had this one before, so I'm going to make a new one though. So I'm going to make a new function app. In the Azure domain, a function app is like literally a function application. Inside there are multiple endpoints that you can build. And so I'm going to use existing resource group that I already created. I'm going to do it as code. So I'm going to call this this is the overall domain. So I'm going to call it Canton Coders Lab, not lab. All right, and I'm going to do code. I've been meaning to play around with the Docker container, but I haven't done it yet. I'm going to select the runtime that I want for this application. I'm going to choose Node.js. You can see here the options, .NET Core, Python, Java, and PowerShell Core. So that sounds horrible, by the way, PowerShell. I don't know how that's going to be. But Node.js, I'm going to do 10, and I'm just going to do Central US because that's close to where we're at.
Hey, Bryce, got a question just directly sent to me, which is awesome. This is a good time to answer it? Or are we going to do programmer interrupt us and throw you off your game?
Unbelievable, Joel. How could you mess up with my flow like that? Yeah, let's go. Let's do it.
Oh, come on. You're a manager during the day. I know you do this all the time. Question about testing. How do you stress test your serverless?
Yeah, I mean, that's a great question. To be honest, in full disclosure, I haven't taken something to scale. So I don't know necessarily what I have or had not or could have done. Is this thing on? Okay. Well, anyways, I can't see you guys anymore. I hope you guys can still hear me. But I think the same things can apply. I mean, you could run some kind of load test to hit it, and there's plenty of metrics that you can see when it comes to like response times and kind of like I guess, really what you're going to look at is traditionally in performance testing, you're looking to see kind of memory, CPU, kind of your servers are crashing, right? That's less likely to happen in this interface. But what you're going to have is it's probably going to be more interesting to find out what is the cost going to rise? How many instances are you having spun up? How long are they staying up? And that's going to all help you drive to what your cost is. So I think it may be shifted and less on can your system handle it, because you're basically challenged like, hey, Azure, can you handle all of my workload? And they're probably going to be like, yeah, we can, as long as you're going to pay us. And so I think it goes to more of a cost expectation versus can your servers handle it? Because obviously you don't have any servers in serverless. You have an app, and then you have an agreement that Azure is gonna or GCP is gonna serve up your app and take traffic, right? I hope that makes sense.
Yeah, Bryce, when are you going to bed tonight? I think we might have to do that tonight.
Run a server test to see if I can hit that 20-cent charge.
Yeah, right.
I'm game. You know it. Yeah. But yeah. I made you a guest account too, so just once you hit $5, just shut it down. All right, cool. Okay, I'm gonna show video 1 second here. Okay, I need some kind of make sure that you guys are still there. All right, so where were we? So I'm going to create, that's a great question, by the way. I hope I answered it sufficiently. So I'm going to make this a Linux operating system. It doesn't really matter because I'm not going to be in the shell anyways. And then this is going to be a consumption serverless mount. I need to look into more. I probably should have hired. I think these other ones, I think there's different settings where you can have probably set some minimum of availability so that maybe you don't, if you're really sensitive on the cold start, right? So I'm going to do consumption because I don't care. And then I'm going to skip to review and create. And then it's going to validate everything's good. And I'm going to create it. So this is going to say my deployment is underway. And then once this is done, I am going to, I'm going to get some things started here though. So first off, so I'm going to go to the shell. Hope you guys can see this. Now this is my Windows PowerShell on my local machine. So I'm gonna go to Canton Coders, my directory, and then I am going to make a new directory that is my Canton Coders lab. And then I'm gonna go to Canton Coders lab, and then let's see, I got some handy dandy shortcuts here. So I need to log in first, but first I'm gonna make sure. Okay, so this thing this thing is good to go. So now we're here. So I'm gonna go. I'm gonna make sure I can log in. So AZ login. I think I'm already logged in, but this is gonna kick me to do the OAuth flow here. So in a second, this will kick me here. I'm gonna say yes. Oh no, that may or may not be my employer if you just caught that. And then now, okay, my shell is authorized. So now what I'm gonna do? I'm in Canton Coders lab. So now I'm gonna initialize a function app in here. So I'm going to func-init. All right, so it's made some bare bones stuff here. And then now what I'm going to do is I'm going to create a new app called FizzBuzz, right? Because we're gonna do that. So I'm going to do func new -- name. I'm going to call it FizzBuzz. And then I'm going to use I'm going to specify the template, which is HTTP trigger. There are other ones here, right? So, and then I'm gonna hit enter, I think. All right, so this was created. So if I look at my directory now, I've got a folder FizzBuzz. So now I'm gonna go to VS Code. I'm gonna add that folder to my workspace. So here we go. Okay, Canton Coders. Canton Coders lab. I'm gonna add this whole folder directory in here. But I'm gonna go into FizzBuzz. So what it created, because I told it I'm gonna make a JavaScript app, and then it made me a base index.js here. So this is a simple endpoint that's gonna take a query parameter and then it's going to return something. So I'm going to obviously do something different here where I'm going to say, okay, let's do FizzBuzz, right? So I'm going to take, and Gugu, this is where the pair programming is going to come in because I don't know if I'm going to be able to handle this kind of pressure. But so we're going to pass in a number, and then we're going to either print, obviously, the number. If it's divisible by 3, we're going to print fizz. If it's divisible by 5, we're going to print buzz. And if it's divisible by both, we're going to print FizzBuzz, right? And by print, I mean just return in the response. So let's just do modulo 15. Let's just do the shortcut here. Then response equals FizzBuzz, right? Am I good so far? Else, if number 3, then we're gonna do response equals fizz. And then else if number modulo 5. Oh my goodness, dude, how are you not catching me on this? Equals 0. Then we got.
I figured you're gonna figure it out eventually.
Yeah, you really always, you're a great coach. You always lead us to the answer for sure with doing nothing.
Yeah, no, exactly. I'm supposed to let you fail so you figure it out.
All right, so the fun is over. So the response is the number, or else it will be FizzBuzz, or it'll be fizz, or it'll be buzz. It looks good to me, right? So instead of this body hello name, we're gonna want to have this just return response, right? So of course people are like, okay, we started with serverless and now we got this some JavaScript scaffolding. So what I'm gonna do is I'm gonna save this file, and then let me look over here. I'm going to now test this locally. So what we do is we're in the main folder, and what I got to do is run this func start -- JavaScript. And so what this is going to be is this is just going to run. This is a nice little Azure symbol. It's going to do a bunch of stuff. It's going to pass through here, and it looks like we did get this app started here. So now what I'll do is I'll just copy this guy, and then I'll go to my Postman, which I didn't clear out. So let me try to hide this, just so you know, whatever. All right, so then we got this as a get, and then I'm going to say the number is 1, right? So we should hit this, and then it returned 1. Then we're off to a great start. So now I'm gonna pass in 5, and then it's gonna say buzz, right? That's right. And then I'm gonna say 6, and it's gonna say fizz. And then I'll do just 9. It should be fizz. I was about to say it should say 9 because you know, my brain. 10 should be what? Buzz. All right, and then we'll just do the both case 15, and then let's see what's the next one that will be just a number 17. Okay. So that's great and all. And so now let's just see, this is mildly interesting. And then let's go here and let's deploy this guy to deploy this to Azure. So I'll go back here to my shell, and then I run this handy function, func Azure function publish. And then I'm going to put Canton Coders Lab, I believe, here. Because that's the function app that I want to deploy this to. So let's just see what this. I started with Azure, like I'll talk over because it had a nice like interface of getting like the test and then the deploy all kind of built in, and I like that. I think this argument GCP has that as well too, and so but what I'm going to do is basically just copy paste code from here to there. All right, so what you see here is not even going to the Azure site. I can go here, and then it gives me the URL that was just created for this app, and then for the security question, it does start with a code. You know, obviously this is a you know, could be better, but you know, could be worse too. So I'm going to copy that, and then I'm just going to go and paste that in here. And then I'm going to do and number equals 1, same thing. And so now this is a deployed app right away. We just made FizzBuzz. So 1, and then let's just do something here quickly. 15 is FizzBuzz. And we can do 100. You know, maybe I should have put a limit at you know, is buzz, you know, etc. So this is you know, this is basically a deployed function app, and you can see here it's 59 milliseconds is the response time, which is respectable for sure for something that is, you know, not fully always running, right? This kind of changes. One thing you know, when we first started, I probably should have showed it was probably in a couple hundred milliseconds because, you know, there is some kind of leaving the thing running. So now what I want to do, because we're going over an hour, so time check for anyone. Apologize. I guess I'll just go quickly over here to show it, to see it here, and then we'll go over to the Google experience. So I probably didn't need to do all that. You know, and so it is up here.
Production?
This is in production Canton Coders Lab. Yeah, absolutely.
Yeah, so it's serverless. Do you have a concept of going through environments before you get to production, or?
I think you do, just like any kind of development. You know, like I think that in you know, in GCP there's a concept of projects, and so we have like a different projects as environment. In Azure, I don't see as much. Probably I would just have a different resource group, and so maybe I would have like a Canton Coders Lab QA, Canton Coders Lab production. So I think similar patterns can apply there for sure. And so let me move over. That's a great question, though, of course. There's a lot of kind of little metrics that you can get that obviously I haven't dived too deep into, but we should be able to see kind of like how many instances were raised, like based on the load, et cetera. But and logs, standard stuff like that. All right, so let's do the GCP side. So let me see if we've got a if we've got a kind of a recycle here. We make this call 96. It's still pretty quick, so I'm not sold that that's like. But anyways, it's serverless. We're not paying for a bunch of VMs running, and we're still getting very adequate performance on a very simple JavaScript app. So the GCP experience, like I said, from my case, is a little bit different. I've got a Bryce Labs here. I probably could have made a project, Canton Coders Lab. But I'm going to go over here to Cloud Functions. And same thing applies. You can sign up for a free account. You just got to give your credit card. But then you really pretty much will run no cost. So these are some that I've made. So I'm going to make a new. The old 19th green over there. All right, so Canton Coders FizzBuzz, I'm going to call this. I'm going to say this HTTP trigger. So this is kind of cool because in GCP, obviously, they've got different kind of experiences. So like I said, we've done Cloud Pub Sub where it's like the function will listen on a topic. There's obviously different Firebase stuff for mobile. Cloud Firestore is like a DB kind of a situation. I'm going to do HTTP again, so it's going to give us this URL. I'm going to say there's a checkbox for allow unauthenticated invocations. And so I'm actually going to check this because I think for having it authenticated, I think is a little bit more convoluted and something I don't want to do right now. This may be better security though than that API key and actually have like a service account like a JSON file that you need to like exchange for an access token. Probably a much better experience, but I'm going to ignore it for now. And so I'm going to select the run. There's a different way. I'm going to do the inline editor, but oh, sorry. You guys can see this okay, right? Or should I zoom in a little bit more? I'm just going to breeze through this. So I'm going to say Node.js 10 again. And here it's like, it's looking for the actual code and obviously the package JSON. So you can, if you build something that has a bunch of requests, like I'll show you some examples of my other Twitch stream or other Cloud Function, you may pull in like a request library or like fetch or something. And so when it builds a container, it will go ahead and pull all those dependencies. So it doesn't have to be something simple, obviously, like FizzBuzz not pulling anything in.
We got a request. If you could zoom in on that screen, that would be really helpful. People are finding this really interesting and they want to learn from you. That's great. That's the whole goal, right? Now if I could just, okay, this has got to be it, right? All right, so here we got, I'm going to do allow unauthenticated, which is dangerous. This is going to be the most exposed FizzBuzz calculator there is. I'm going to say Node.js 10. And so here, like we have, we could just code in here, obviously, or there's this little thing where it slides out and it's still like a pretty bad experience though, right? So what I'm going to do is it's just looking to have this method and then the code in here. So what I'm going to do is I'm just going to take the code that we already have done here, basically this part. I have to change it a little bit. So I'm going to take these guys, which is the heart and soul of this operation, and then I'm going to go back to the browser, and then I'm going to paste that in here. Actually, I'm going to keep that just for a second. So I paste that in there. I'm going to do some formatting. And then I'm going to say, okay, rec query number actually. So this is actually fine. Yeah, obviously it's no. So and then the response here, it's looking to send the message. I'm going to actually just send the response. I could change this. So this could be like, okay, this is FizzBuzz Canton Coders, right? And then the only thing is you got to specify it what method to function execute. So if you had multiple methods in here and you had some automation and you didn't want to have a separate one, you could just always have the same code, and I'm sure there's some automated way to do that. And then you just have to specify for the Cloud Function when you're creating it, what is the method to trigger on the API call. So basically right now we're saying
back to that diagram, when this API request comes in, we did nothing to set this part up. It knows that it's going to indicate this cloud function, and it's going to do all the necessary things to get this node app running on a container with the proper runtime to service that request. You can add environment variables here that the code can pick up. And then, so that you can make, to your question, Google, across environments, you could have the same code, but then control the different environment-specific variables, obviously, from there. But I'm going to skip all of that because this is super simple. And then I think that at the top, I think that's all I got to do. So I'm going to go to create here. It's creating this function. While we're waiting for this, let me just show you, maybe just so you can see kind of, you can do a little bit more, in-depth stuff. Obviously, granted, this isn't super in-depth, but if we were to go to edit this, this is something where it's like when it listens on a couple streamers going live, it will send a Slack. So sorry, maybe this will be better. Okay, this was because for the webhook, there needs to be a challenge to say that this actually exists. We're using the request library here. We're getting the body, and then we're then making a request to the Slack webhook with the name of the streamer that's going on. And then so actually, I guess that's actually pretty simple. But I just want to show here that we can require request, and you just have to then add request in the dependencies. So just like what you can do normal, you can do with the cloud function there. So let's go back here and then see if our FizzBuzz is done. It looks like it's done here. So I'm going to go back here, and then I'm going to grab the endpoint again. So I'm going to copy this and then go to Postman. And then so this time I'm going to remember, and let's compare like first time versus last time. So if we do this, hopefully it'll work. This number equals, let's just keep it consistent. We'll do 1. So if I send on this, we get 1, and it was 394 milliseconds, right? That seems, respectable. And then we go to the next one, and it's obviously much smaller. Granted, normal operations have that because obviously databases are caching things, queries. And so, this isn't all attributed to just singularly cold start problem, right? But I think that's kind of what I'm trying to get at here. And then obviously this took 3 seconds. So obviously that's super bogus. But I think that kind of goes into the function environment is a little bit more volatile than a fully, you're running 20 VMs at something. Obviously, that's going to perform better. But if you want to pay $20,000 a month in server costs, you're going to get Supremo performance. So I think that's kind of where the trade-out is. I do know. So I'm almost done here. But if we go to, I didn't even try a different thing. What if this is broken? So if I do 3, we got Fizz, and then we'll just do 15, we get FizzBuzz, right? So if we go here, we can see in the general, you've got some things here about, I may need to, minimize this a little bit so I can, I think the logs may not have come in quite yet here. Where's the refresh? Maybe I'm missing it. But this does have some different things like the invocation. So you can see when there was requests, when there were not, kind of how long they stayed. It's kind of hard to really understand it. I think you may need to be smarter than me on that one, but there is ways to kind of visualize that and the like. But I think we've gone almost an hour and a half here, so I'm pretty good to start wrapping this guy up. But anything else, I'm super passionate about this stuff. It seems kind of simple. I just think it's just just to summarize on it all, I think it really it's just like a completely different way of architecting and taking advantage of kind of cloud compute. I think cloud in general is awesome for what it abstracts, and then this is just like kind of to the core, albeit with some trade-offs. But I think that the ability to be able to service requests and not have a VM running constantly every second of the day, I think is extremely cool.